Imagine it's the year 2080 and you're responsible for analytics inside an organization. You don't begin by opening a dashboard. You begin with objectives: reduce preventable failures, grow sustainable revenue, protect customer trust, operate within energy and privacy budgets, and comply with whatever auditability requires in that era. Quietly, almost invisibly, an analytic system proposes actions, simulates trade-offs, quantifies uncertainty, and logs every decision for future review. It doesn't just describe what happened. It guides, constrains, and in some cases acts. That vision may sound futuristic, but it is not fantasy. It is the logical continuation of patterns already underway. Analytics has moved from reporting the past to predicting the future, to increasingly shaping decisions in real time. In some domains, it already executes constrained actions. Before we go further, we need intellectual honesty about the word predict. Predicting tomorrow's demand is fundamentally different from predicting analytics in 2080. The longer the horizon, the more uncertainty compounds. Technology shifts, economic incentives evolve, regulation expands, public acceptance changes. The right question is not, can we know 2080? The right question is, can we identify plausible pathways and prepare intelligently? That is the discipline of foresight, replacing false certainty with structured uncertainty. To think clearly about 2080, we follow 5 principles. First, anchor on history. Second, identify strong drivers with evidence. Third, acknowledge constraints. Fourth, build scenarios rather than single forecasts. Fifth, translate those scenarios into practical preparation. Let's begin with history. Analytics did not begin with machine learning. It began with record-keeping and decision-making. In the 1960s, computing was centralized and expensive. Reporting was batch-based. Then came a foundational breakthrough: Edgar F. Codd's relational model in 1970. The importance was not just technical. It separated logical structure from physical storage, enabling flexible querying without rewriting entire systems. That shift transformed analytics from static reporting into an evolving capability. The second anchor is the economics of compute. Gordon Moore's 1965 observation about transistor density turned into decades of exponential improvement. Compute became cheaper and more powerful. That did not merely accelerate existing analytics, it enabled new forms entirely: granular measurement, continuous experimentation, automation. By the 1990s, the field matured. Knowledge discovery in databases clarified that analytics is a process, not just an algorithm. CRISP-DM formalized project phases. These frameworks reveal a truth that still applies. Analytics. Failures are often not mathematical failures. They are failures of framing, governance, validation, and deployment. In 2004, MapReduce made distributed processing accessible. Analytics scaled horizontally. Then cloud computing and open-source tooling democratized infrastructure. By the 2010s, streaming architectures reduced time from event to insight. Analytics became continuous because measurement became continuous. Then came a deeper shift. Machines began understanding and generating language at scale. The transformer architecture in 2017 redefined sequence modeling. Scaling laws in 2020 showed predictable performance improvements with compute and data growth. This changed workflows. Professionals began interacting with analytic systems conversationally. Intent translated into models and explanations. History shows a pattern. Analytics moves closer to reality through better measurement, closer to action through automation, and closer to trust through governance. The future of analytics is not just technical. It is socio-technical. What can be built? What should be built? What will be accepted? So instead of predicting a single 2080, we identify drivers and constraints. Assume compute continues improving, but through heterogeneous architectures and energy efficiency rather than pure transistor scaling. Assume networks become more reliable and dense. Assume regulation expands where analytics affects rights and safety. Assume energy becomes a first-class constraint. Assume authenticity becomes an engineering requirement as synthetic content grows. Assume cryptography evolves to withstand quantum risk. Under those assumptions, 10 drivers shape analytics toward 2080. First, compute economics. Analytics will increasingly operate under multi-dimensional budgets: cost, latency, privacy risk, energy. Compute becomes not just a technical resource but a governance signal. Second, AI architecture. Analytic systems likely become modular swarms of planners, evaluators, and domain specialists rather than monolithic models. The critical competence becomes system design and uncertainty propagation. Third, sensing and digital twins. As measurement becomes continuous across infrastructure, health, and industry, analytic systems model reality dynamically rather than episodically. Fourth, distribution. Edge processing and federated learning reduce centralization of sensitive data. Data stays closer to origin unless aggregation creates clear value. Fifth, synthetic data and content. Synthetic generation enables simulation and rare event modeling, but introduces authenticity risk. Provenance becomes essential. Sixth, governance and regulation. GDPR, AI regulation, data access laws, these shape permissible design. Analytics becomes partly legal engineering. Seventh, energy. Data centers already influence electricity demand planning. Energy efficiency may shape architectural choices more than algorithmic elegance. Eighth, security and post-quantum cryptography. Trust depends on integrity. Crypto agility becomes foundational. Ninth, human interaction. Whether or not brain-computer interfaces mainstream analytic interaction grows more contextual and conversational. Professionals translate values and objectives into machine-optimizable forms. 10th, incentives. Externalities, privacy harm, environmental cost, are increasingly priced. Ethics frameworks influence market legitimacy. But drivers alone are incomplete without constraints. Physics constrains compute. Infrastructure and materials matter. Energy grids matter. The data paradox constrains truth. More data does not guarantee better models, especially in a synthetic content world. Governance capacity constrains compliance. Regulation requires enforcement and institutional maturity. Security threats constrain openness. Repeated integrity failures could fragment ecosystems. Social license constrains measurement. Societies reject uses they perceive as illegitimate. With drivers and constraints identified, we build scenarios. Scenario 1. Ambient autonomy. Analytics becomes embedded and agentic. Systems sense, simulate, and act within policy-defined boundaries. Humans define objectives and review exceptions. Trust infrastructure, evaluation, provenance, auditability matures alongside autonomy. Scenario 2. Regulated minimalism. Energy and liability pressures tighten. Analytics advances but cautiously. Models are smaller, domain-specific, and privacy-preserving. Federated learning and localized processing dominate. Scenario 3. Fragmented black boxes. Trust failures and weak standards drive fragmentation. Closed ecosystems optimize internally but lack interoperability and transparency. These scenarios are not predictions. They are structured possibilities. To make them concrete, imagine a retail supply chain in 2080. In ambient autonomy, sensors update continuously, simulations optimize procurement within carbon budgets, and decisions log automatically for audit. In regulated minimalism, most analytics runs locally to minimize risk. In fragmented black boxes, suppliers and retailers operate proprietary models with limited coordination. The lesson is practical. The future differentiator is not generating insights. It is engineering reliable decisions under constraints. For professionals, this means mastering risk management, evaluation, privacy engineering, distributed systems, and uncertainty communication. Technical fluency remains essential, but governance fluency becomes equally critical. For organizations, preparation means building foundations, metadata, lineage, interoperability. Treat risk management as operational discipline, not policy theater. Monitor energy use per analytic decision. Design for cryptographic migration. Invest in provenance systems. For educators, analytics must be taught as a socio-technical discipline. Statistics, systems design, ethics, regulation, and energy literacy belong in the same curriculum. Now consider societal impact. If autonomy dominates, risk lies in diminished human agency. If regulation dominates, risk lies in concentration of power among those who can afford compliance. If fragmentation dominates, risk lies in opacity and inequality. Trust becomes measurable engineering, not marketing language. A simple mental model captures the trajectory. Analytics evolves from rear-view mirror to navigation system to constrained autopilot. The question is not whether autonomy emerges. The question is where, under what governance, and with what override mechanisms. So what can you do now? Document assumptions explicitly. Add lineage. Make models reproducible. Learn evaluation deeply. Calibration, robustness, drift. Understand privacy risk practically. Discuss trade-offs clearly. Accuracy versus explainability. Automation versus oversight. Performance versus energy. If you lead, build cross-functional muscle between data, security, legal, and domain teams. Implement decision logs. Pilot privacy-preserving methods. Prepare for cryptographic migration. Monitor energy intensity. Treat analytic outputs as hypotheses guiding controlled intervention, not as unquestionable truth. Now return to the central question. Can we predict what data analytics will look like in 2080? We cannot guarantee a single outcome, but we can identify forces, design for resilience, and prepare for multiple plausible futures. That is strategic advantage. If you work in data, choose one trust upgrade you can deliver in the next 30 days. Better documentation, stronger evaluation, clearer lineage, improved privacy control, or energy monitoring. Then choose one capability to study deeply over the next 90 days. Causal reasoning, AI evaluation, governance engineering, or distributed analytics. The future of analytics is the future of decision systems. And the teams that win will not be those with the flashiest models, but those who can prove their decisions are intelligent, constrained, and trustworthy.